Welcome to Unit 2, Lesson 10, Multiplicity Practice Problems. All right, sketch a graph of the function defined by g of x. So the first thing we need to do when sketching functions is find the leading term. We're going to find the intercepts, the x and the y intercepts. These are the first things that we have to do. So to get the leading term, multiply the x's together. X times 7x. There are 3 x's there, so we know we have 7x cubed. There are 3 factors here because this is in factor form, so we're going to have 3x intercepts. I should probably do this in a different color. Let's do this in a different color. Let's do this in red. All right. So we set each factor equal to 0. Add 3 on both sides and solve. Set each factor equal to 0 and solve for x. Basically what it comes down to is switching the signs. Now 7x minus 2 is a little bit different. Because we have a leading coefficient, we got to do a 2-step process here, but we know how to solve equations. And now we have 3 factors, we have 3 x intercepts. 3, -1, and 2/7. Now, our next step is to find the y-intercept. So the y-intercept, what we do is multiply the constants. -3, +1, and -2. -3 times -2 is 6. So our y-intercept is at +6. And now we are ready to finish our graph. Our leading term of any polynomial will always tell you what the shape of the graph is going to be. It's positive because there's no sign. So positive starts low and they end high. So let's put our factors on. We have -1, and 1 would be over here. 2/7 is, I don't know, about right there maybe. Because if this is 1, 1 would be about there. 2, then 3. 3 is here. 1 is there. And I'll put that in the same color. 2/7 is right there. Our intercept is +6. So what we're going to do is we're going to come up, come down, and go back up. So something like that. It's not exact. It's a sketch. But you can put this in a y equals on the calculator and see what it does. Okay, now let's take a look at problem 2. Now, we have a square term here. So what that tells us is that we have x squared times x. Our leading term is going to be x cubed because of the square. So this tells us that the graph is going to double back on itself. So now for the x-intercept, set each factor equal to 0. X plus 1 equal to 0. X minus 4 equal to 0. Add 4 on both sides. Subtract 1 on both sides. Basically, what it comes down to is switching the signs. So our x-intercepts are -1 and +4. Now for our y-intercept. Oh, let's do this in a different color. Y-intercept. Okay. Multiply your constants. 1 squared, don't forget to square it, times -4 is -4. Okay, so -4 is down here. Our x-intercepts, we'll put them in red, at -1 and +4. So now to graph this, we know it starts low. It doubles back at -1, comes down through 4, and it goes back up. The square tells us it doubles back on itself or rebounds. Okay, let's look at number 3. Use your calculator. Put all of these into y1, y2, y3, y4, and so on and so forth. And then graph them. And then we know on your calculators, the colors come up. So let's do them one at a time. I have 1, 2, 3, 4 products. So I'm going to have x to the 4th. 3 times 4 is 12. X to the 4th is even. And I have four factors, so I'm going to have four intercepts. And it's positive x even. It starts high, it comes, and it's going to look something like that. I didn't graph it, but once you graph it, it should look something like that. This is not exact. I did not take the time to find the x intercepts or the y intercept. So this is just a rough graph. Okay, for the next one. Now watch the negatives. Negative x times negative x is positive x because of the square here. And times negative x again. Our leading term is negative x cubed, which tells me it bounds back on itself at -3. So it starts high. It's going to do something like this and do something like that. I don't know exactly what it's going to do, but it's going to do something like that. But you should put these in the calculator and look at the graphs. I could be over to the left or right too far. Okay, let's look at C. So what I'm going to do is I am going to distribute here the x to the fourth first. Negative is out front. 4x to the fourth minus 3x to the fifth. Then I'm going to distribute my negative. I get 3x to the fifth minus 4x to the fourth. Okay, I know that positive x odd is, and I could do some other things to get the graph right, is going to start low and end high. It's going to do something goofy at 0. But I don't know what the intercepts are, but it's going to start low, do something goofy, and go high. That's what we are going to do. It's probably going to worm through at 0. Let me redraw this, because if we look at the original function, x to the fourth is our thing. So it's going to worm through at 0 because it's going to double back at 0. Giving us a graph that doubles back at 0, starts low, ends high. Positive 3x to the fifth is our leading term. Okay, so 6 minus x to the sixth power is going to look like, well, it has a root. So basically what you do with 6 minus x is you switch it around. It's negative x plus 6. And then when you set that equal to 0, you get 6 is equal to x. And it's an even exponent, so it doubles back at 6. So it's going to look something like that. Okay, let's look at number 4. Which term can be added to the polynomial expression to make it a 10th degree? To make it a 10th degree, we'll add an x to the 10th term. Remember, the degree equals highest exponent. It does not matter how many terms you have. The highest exponent in any polynomial is the ENT, is the degree. Degree equals the highest exponent. Okay, this one is from a long time ago. Now, the 2 out front means you double the height of all the dots. So the solid line is F, and the G is the dotted line. And how do we know? Because all the dots should be double what they are correspondingly. So this dot is twice as far away as this dot. So this is 2. This is times 2. This is times 2, and so on and so forth. This is times 2. All the dots are twice as high in y as they are on each function. Okay, state the degree and end behavior. The degree is the highest exponent, so it doesn't matter where it is. And the end behavior, x even, positive x even starts high and it ends high. So you can graph it in the calculator. It should look something like that. It could be too far over to the left or the right, but roughly it's going to look like that. And now one of these questions, we have more than one possibility. So our constant term is odd and is positive. So the degree of the polynomial is even. That is true. Both ends end in the same spot. That tells us it's even. The leading coefficient is negative. It faces down, so the leading coefficient is negative. The constant term of the polynomial is positive because the constant term is the y-intercept. So the constant term equals the y-intercept. And those are our practice problems for today.